recordings and all, yes, download access won't be there. You can access the recordings from the Google Drive only. Okay.
Okay, thank you.
Yes, so let me divide the entire window into 3 parts. Sir, if you look at the tendency 10 to 15 years back, 10 to 15 years back, okay, so the volume of the data would be something like kilobytes, megabytes, and gigabytes. This is the volume of the data what we were managing mostly. And varieties of the data, different varieties of the data, if you look at, mostly we were using the structured data only at that time. And with respect to this limited volumes of limited varieties of the data, limited volumes of limited varieties of the data, the performance of the processing is also extremely good. Velocity or performance is extremely good. Okay. But whenever the volume of the data has been increased drastically, meaning terabytes, petabytes, hexabytes, gigabytes, and so on, with this much of the huge volumes of the data, where exactly I can manage, and along with the structured data, semi-structured data, and totally unstructured data we are getting. So how do we handle these many different varieties of the data? Okay, this is an open question. So because of the increase in the volume of data and increase in the different varieties of the data, in the way of processing the data as well, good amount of performance related problems. We are getting the performance related problems. Performance related problems we have been getting. Okay, so that is where we are observing here. So if this is the case, there is a need of a new framework or technology, because in the traditional RDBMS tables are using the traditional technologies. We cannot process this much of the huge volumes of different varieties of the data, and it is not only, there are two major problems over. Storage is a problem over with respect to the very first one is volume, and second one is different varieties. And in the processing also we have a problem with respect to majorly performance, meaning velocity, and the next one is veracity, meaning consistency related problems. So these are the different big data related challenges. So this is what we used to call big data related problems. Sir, so in order to overcome these big data related problems only, Hadoop framework has been evolved in the market as a popular solution. So when you say big data is a problem, big data is a problem, Hadoop is a solution. When you say big data is a problem, Hadoop is going to be a solution here. So what exactly Hadoop is doing? Sir, it is meant for dual purposes. The very first one is big data storage. The very first one is storage. And the second one is big data processing. Okay. It is meant for dual purposes, meaning within one framework only we can accommodate two major aspects, storage and then processing. So as far as storage part of the data is concerned, we are making use of Hadoop distributed file system. What is the full form, sir? Hadoop distributed file system. Coming back to processing, we are having multiple tools over here. Either we can use at a core level MapReduce or pick or hive, whatever it might be. So these are the different components what we are going to use. But here one important point I would like to tell you. Sir, if at all there is a problem or there is some advantage in MapReduce, same thing will be applicable to pig as well. Meaning internally in our pig also we are making use of MapReduce only. Everything it will convert into MapReduce jobs. Whenever I am saying hive also, internally the conversion is going to be with respect to MapReduce only. Okay, now sir, in order to overcome the big data related storage problems and processing problems only, we are moving on to Hadoop solution. But from Hadoop, if at all you have to move on to, sir, if at all we are moving to Spark framework, why? What is the reason? Is the problem with respect to Hadoop storage here? Is the problem with respect to Hadoop storage here? Or the problem is with respect to Hadoop processing here? Where exactly the real challenge? That's what we are going to see. Where exactly the real challenge? Okay. Yeah. So now here we are going to say, sir, if you look at the advantages of our Hadoop distributed file system, whether it is kilobytes or megabytes or gigabytes, terabytes, petabytes, exabytes, zettabytes, and so on. Any volume of the data we are going to store, yes, we can store on top of HDFS. And secondly, whether structured data or semi-structured data or completely unstructured data, any varieties of the data also we can store over here very well. So that is where we are going to make use of HDFS. Any volume and any varieties perfectly we can store on top of Hadoop distributed file system. Okay, next. So here, coming back to, these are the advantages. Coming back to the drawbacks of HDFS. Okay, so here, in order to store any volume of the data, okay, so sorry, here the first drawback is from HDFS, always you will access the data. Okay, I will write only the points in a sequential manner, sequential accessing. So record by record fashion only we are going to access the data from HDFS, Hadoop distributed file system. Because of this particular record by record kind of the sequential accessing, what is the other problem we are going to see? High latency, meaning high response time. High response time. Okay. So before you are going to conclude, these are the two practical challenges with respect to these two particular problems. We are going to call so there is another component called HBase, one of the NoSQL database. NoSQL database. Okay, so what is the advantage of HBase? We can access the data. We can access the data in a randomized fashion. So because of this random access, what is the other advantage we are getting? Low latency. In a low latency manner only, we can access the data. Low latency meaning low response time. In a quick span of time only, we will get the entire data. So the point here is, within the Hadoop framework itself, before you are going to conclude, these are the drawbacks of HDFS by the means of one more other component of Hadoop, HBase solution also giving. So that's where I'm not going to consider these two particular problems as the problems only. No. Okay, so as far as big data storage is concerned, any volume and any varieties, including all the recent technologies also, Hadoop HDFS is having its own identity. It is really, really excellent component. So there is no question about HDFS. It is perfectly all right. It is perfectly okay. Now, what about processing related problems? Yeah, look at here. Now, what are there any problems with respect? Okay, from the storage side, you are saying there is no question. HDFS is really excellent. Okay. What about processing related challenges using MapReduce or Hadoop processing challenges? Yeah, look at here. I will just write it over here. So what are the different difficulties, different problems with respect to Hadoop processing? So the very first one is Hadoop is doing the processing in a disk-based manner. Disk-based manner. Hadoop is doing the processing in a disk-based approach, disk-based manner, meaning that is either input data, either reading the input data or writing the processed output data only on HDFS, because Hadoop doesn't know how to access the data from in memory. Sir, here I am introducing a keyword in memory, nothing but RAM, RAM or cache. Okay, so there is no such concept of processing the data from the cache. So that is completely not known to our Hadoop framework. As part of reading the input data or writing the output data, also predominantly Hadoop is making use of disk-based processing only. Indirectly, it is keeping the data on HDFS, reading the data also from HDFS only. So this kind of the model is a good one up to gigabytes, terabytes kind of the data. But as and when the volume of the data has been increasing to petabytes, exabytes and more, definitely it will have a huge impact on the performance. This is the first drawback. Second, sir, there is something like map reduce. So what is map reduce? It is the core processing component of our Hadoop. If you look at the map reduce processing, there are three phases we are having. The very first one is mapper phase. Okay. I have joined this session. So is that? Sir, I joined this session only to inform you that I got placed in Deloitte with the 16.7 lakhs per package, batch 21. Oh, great. Congratulations, Roshan. Yeah. Yeah. So the very first one
Thank
is
you, sir.
yeah, mapper phase. So transformation phase. Okay. Second one is sort and shuffle phase. And the third one is reducer phase. So here, as of now, you can just assume like first level filtering, second level filtering, and third level filtering. These are the three particular aspects: first level, second level, and third level filtering. Okay. So what I'm trying to say here, to understand better, to these things only to understand better, let me open one document here. Yeah. So these are the map reduce phases: mapper phase, sort and shuffle, reducer. As I already mentioned, it is going to read the input data from HDFS only. Once the mapper phase is completed, it is only the intermediate phase, sir. It is going to write the output data to HDFS only. Once the mapper phase is fully completed, 100% it has been completed, then we are going to read the same kind of the output data, and HDFS is going to write the output data to our HDFS only. Sort and shuffle phase, once it has been completed 100%. Okay, we are going to read the data from HDFS and we are going to produce the output data also on HDFS. Once it is also been completed. Okay, So then processing is going to be completed here. So all the three stages are going to be completed in a sequential manner. In a very sequential manner, the processing is going to be completed here. So though we are keep on saying MapReduce is a distributed and parallel processing system, we are not really achieving that parallelism in all the three phases. Here all the three phases are happening one after another, one after another, but within a single phase. Yes, you are right. We are going to see the parallel processing only here. That is correct. But among the phases, we are not going to see the same kind of the parallel processing. It is always going to be in a different fashion only. So this is how you are going to see the complete data. Okay, so all these three stages are going to happen in a sequential manner only. So because of this step-by-step approach also, it is going to take some more time while you are processing the data. So that is what my another problem. MapReduce is always processing the data in step-by-step manner among the three stages, among the three phases. Because of this processing related delays for huge volumes of the data. So this is also one more other drawback with respect to MapReduce. Of course, within any single phase, we are achieving the parallelism, but it is not among all the three stages. It is always step-by-step manner only. Okay, next. So if you look at processing in the real world, it has been divided into three categories, sir. The very first one is batch processing. Second one is near real-time processing, NRT. So this is nothing but transactional processing. And the third one is real-time processing. So that is nothing but RT, real-time processing. Okay. So here when you look at batch processing, it comes under OLAP, online analytical processing. RT, real-time processing. So this is nothing but OLTP, online transactional processing. This is also OLTP, online transactional processing. Okay, so among all the three types of the processings what we are having, Hadoop can only accommodate this one. Hadoop can only accommodate okay. Hadoop can only perform batch processing alone. Yeah. But if you look at the real-time processing or near real-time processing, there we cannot make use of Hadoop. What is the reason? Because if you know everything, the data has to be there on HDFS, which is a immutable system. In real-time processing, every second by second, the processing is been keep on changing only. The data is keep on changing only. So it is a complete immutable data, changeable data. But HDFS itself is a immutable file system. So how can we do the real-time processing or near real-time processing through Hadoop? That is what the huge drawback. Okay, so next. So these are all different design level problems or the difficulties of the Hadoop processing or MapReduce processing. Sir, there is a as per data locality design rule, DL, data locality design rule. Before processing commence, input data must be present on HDFS. Okay, so as part of the same, now look at here. I will explain one more other problem. Sir, I will save this particular document and I will move on to the next one. Okay, otherwise let it be. Yeah, so let us say this is where Hadoop, sir. Here Hadoop is meant for storage and processing. Storage and processing. So as far as storage is concerned, HDFS is the component. For processing, we are going to make use of three tools: MapReduce, majorly, pick, hide. Okay, now, so if at all you are going to process the data, if MapReduce has to apply the logic, the input data must be expected on HDFS only. Here only the data must be expected over. Now pick, the data is expected here only. Hide, the data is expected here only. Okay, yeah. So this is how we are going to keep the data under HDFS. Now, so here what we are trying to say, for example, if the data is here, then only these particular tools will work. But one of our customer is saying, Cisco, let us say, their current storage is going to be under Oracle database table. Processing is going to be Java, for example. So, okay, processing we can leave it. So, if at all we have to, if the data is been part of Oracle database tables, our MapReduce, Pig and Hive, they don't know how to process this particular data. That is where, if the data is here only, they will start the processing. So now what is lagging? From here to here, we have to bring the data. So in this regard, we are supposed to use one third-party tool, some integration tool called Scoop. How exactly Scoop is been coming over SQL on Hadoop. By using this Scoop component only, we have to first of all bring the data here. Okay, so there is a dependency on the Scoop component. For example, in the other customer, let us say Amazon. Here the storage is going to happen under live log servers. Okay, yeah, live log servers. So here, yeah, so if at all it is the live log data, how can I bring the same kind of the data here? So here we are going to make use of either Flume or Kafka. Either Flume or Kafka. We are going to use to bring the data to our HDFS. So that is where I'm saying. So in order to get start the processing itself, we are supposed to use some third-party tools to bring the data to our HDFS, because without having the data on HDFS, you cannot even start the either MapReduce processing or Pig processing or I processing. If you are using some particular tools in between, definitely the performance will be degraded. It is something like there are two people are communicating. First person knows only Telugu language. The other person only knows Tamil. Okay, so whatever he is saying in Telugu, other person will not understand. Whatever the other person is saying in Tamil, the first person is not understanding. So if both of them need to communicate with each other, they need a translator who can better understand Telugu and Tamil as well. Something like here also, these particular integration tools are known as the translators. They have to convert the things from the Oracle database point of view to the Hadoop understandable format and vice versa. Here also the same thing. Okay, here also the same thing. So they will act like the translator. So obviously because of using these translators or the third party tools, performance will be degraded. As part of the same, we must have to use some third party tools like Scoop, Flume, Kafka, etc., which will, because of which performance will be degraded. Yeah. So this is also one more other drawback by using this particular Hadoop processing. And the next one is something like top to bottom approach. Top to bottom approach of Hadoop or map reduce processing. So what does it mean, top to bottom? Yeah, look at here. For example, sir, one Cisco use case only let me discuss. Customer Cisco, a telecom domain customer, he has been providing 100 crore records, which is under 1 terabyte of the data. Okay, so he has been providing all the log data only. All the log data only. Okay, so now here we are getting all this particular log data, 1 terabyte of the data. So first of all, we have to get a count of customer. Sir, if you are not asking any questions, can you please go on mute? Rohit, can you please go on mute, sir? Yeah. So customer requirement is something like count of all error records. Second requirement is records starting with error keyword. Third one is records ending with error keyword. Yeah. So now, if at all we are making use of Hadoop, how exactly the things will be? If at all you are making use of Spark, how the things will be? That's what we are going to elaborate here. So when we are using the Hadoop framework here, for example, so here, first of all, as you all better know, we have to load the data on HDFS. Without having the data on HDFS, nothing is going to happen. Now, this particular data only will get divided into blocks. Sir, it is the internal architecture of our Hadoop, sir. The data will be initially divided into blocks. From there only, splits are been coming. On top of the splits only, we will start with our first phase called mapper phase. On top of the mapper phase output only, we are going to apply the sort and shuffle phase. Once the sort and shuffle phase is completed, reducer phase we are going to start with. Once reducer phase, final result we are getting. Okay, so here we are having 4 lakh records here. 4 lakh records. We are getting as a errors. Number of records, error records are going to be 4 lakh records. Out of 1 TB of the data, meaning to say the initial volume is 100 crore records. So my point here is, sir, more than 90% of this particular processing, more than 90% of this particular processing, we are making use of this particular all the 100 crore records. Finally, after the final phase only, we are going to see these 4 lakh records here. That's how we are getting the complete data. So even though we know there in the log data only, we are having a warning related log, debug related logs, info related logs, and error related logs. But what is the required data? If you look at all the three use cases also, the very much required data is error data. But then why should we use all the other records as well here? It's of useless. But still more than 90% of the case also, we are going to make use of this all the data, and then finally we are giving 4 lakh records only our outcome. So to get these 4 lakh records, it has been taking 100 hours of the time, for example. 100 minutes of the time we are getting. 100 minutes of the time we are getting to get this result. But if at all you are doing the same use case using Spark, how the things will be? So step 1, here what we are going to say, we are going to say keep the data on HDFS. First, step 1 is referring or opening original input data. That is what step 1. So we are going to call this one as a base RDD. So it's not the right platform to talk about what is RDD and all the stuff, but this is what we used to call first step and base RDD. Now second step. Even in Spark also it is a 3-step process. Step 2, we are going to convert the raw data. We are going to convert the raw data into the required format. Okay, so here from all these records we don't require all this data. From the raw data only we are going to convert into error based data. From the raw data only we are going to convert into error based data. So here we are reading the original 1 TB of the data. Not all the 1 TB of the data has been coming, only the error based data only we have been taking out here. And so this is what we used to call transformed RDD. Okay, yeah, fine. So now step 3, action RDD. So it is something like applying the computations. So this is what we used to call action RDD. Okay, so okay, I already written. So here we are getting the count of the complete records only. Count of error records. Sir, in our map reduce, if you closely observe here, it is always going to do the top to bottom kind of the processing only. Here we cannot avoid any kind of this step. So it is always going to be top to bottom. But here when you look at when you look at this Spark, so here always it is going to be from bottom to top only. From bottom to top we are going to make use. Okay, from bottom to top. So meaning to say, as and when we are reading the original data, here itself the processing will never ever start. Here also the processing will never ever start. But here, yes, by taking the step 3. So you need all the count of error based records. Where exactly we are getting the error records? In the second step. But to get the error records, where is the original data? From there only I have to get the error records. So here only we are getting. So in this bottom to top fashion only, our Spark processing is always going to happen. So because of the same reason, here we need all the error based records. Now it is going in the second step only we are getting. So to get the error based records, first of all, where is the original data? So it is going to all the 100 crore records. It is reading the first record. There is no error, leave it. Second record, there is no error, leave it. Third record, there is error, take it. Fourth record, there is error, take it. Fifth record, there is error, take it. Next record, no error, leave it. So likewise, it will only scan the complete 1 TB of the data. However, only the error based data only it will read it and keep it in the cache. So meaning in this step only in the cache, it is going to keep 4 lakh records. 4 lakh error records. Now the actual processing is also only happening on the 4 lakh records only. If you look at in Hadoop, the actual processing is happened on the 1 terabyte of the data, almost more than 90% of the processing. That 1 TB of the data only be used here. But here we are only using this 4 lakh. Excuse me. These 4 lakh records only our actual processing. That's where we are getting our complete output data within 1 minute of time only. So here it is taking 100 hours of the time, whereas in our Spark it has been taking 1 minute of the time only. So that is where the beauty of our Spark processing. Look at here. It is taking 100 hours, 100 minutes of the time, whereas here it is only taking 1 minute of the time only. So Spark based processing performance is 100 times faster than Hadoop based processing performance. So clearly with a use case only I have discussed. Okay, so now likewise these are all the different problems what we have been facing with respect to our Hadoop MapReduce kind of the processing. So now
One
let's come
question.
to yes.
Previous diagram, which you have explained with the 1 crore, 100 crore records.
Yeah.
Yeah. Here. So I'm good with this Hadoop processing, and coming to the Spark, it is going from bottom to top as per my understanding.
Correct.
So at the first step, 1 terabyte, it is checking for error message in the record. So when it is scanning 1 terabyte, that will be picking from the HDFS only, right?
Yeah, it is the original data. It is been reading either it might be reading from HDFS or our local file system or table,
So then,
whatever. For Spark,
then
there is no such
HD,
man.
HDF,
Sorry.
sir. HDFS means it will go to the blocks and splits, mapper phase, these all right.
No, no, no. As part of the processing only, it will read all the splits and all, mapper phase and all. But only HDFS, storage point of view alone, if you are looking at, only it will read it through HDFS only, nothing else. No split concept. All this particular stuff will come in the processing only here, whatever I'm highlighting.
Okay. So once we triggered a query, then it will pick from the HDFS and save it, and post that will go to the second step, and at the third step it will give the results, right?
No, no, it is in a reverse order. So in Spark, what is happening? Whenever you invoke, whenever you are writing the base RDD, at this step processing will not get started. No, because I don't know what should I do with all this particular data. Until and unless my requirement is not clear, I will not start the processing. That's what Spark is saying. Here you are saying convert the raw data into error-based data. Compared to my step one, here you have provided some clarity. But still, what should I do with the error data? Still, I am not clear. It will not start the processing. Here you are saying I need the count of all error records. Very clear requirement. So in a bottom to top fashion only, from step 3 to it will go to step 2. From step 2 to it will go to step 1. Then only it will start scan the data. Okay, so where exactly my error based records and all. That error data only it will take it and keep it in the cache. So meaning ideally speaking, though our entire volume of the data is 1 terabyte, What is the exact data it is taking into our cache? Only these 4 lakh records. So this particular data volume only we are going to leverage as part of our processing, but not 1 TB of the data. What exact data we are storing in the cache, that itself is going to be matter for our processing result. Okay.
I'm just confused. And like, so if you use execute a query, select with like condition error count. So first it will come to the step 3 action RDD, right? So post that it will enter into the convert the raw data means what it will do exactly in this example.
One more time I'll explain. Please listen. In the step 3 only we are providing the clarification. We need the count of all error based records only. But to get the error records, where exactly we are writing that transformation logic in the step 2. From the raw data only, convert the data into error based records. That logic we are writing in the step 2. But where is the raw data located? Then it will go to the step 1. This is the raw data. So then whether the data is on HDFS or local, wherever it is, it will just scan the complete data. So wherever you are having the error records here, it will not blindly load all the 1 TB of the data. No, because we don't require that complete data. As per requirement only we are reading. Whereas in Hadoop MapReduce, blindly it is taking all the data and then doing the processing. That's where I already added one point. Here it will get all the debug related records, okay, info related records, warning records, all the data is been coming. But here to the point, whatever we required, only that data only we are going to take it here, only the slim data. So though there might be all this combination of the data here as well, but are we loading all the data? No, exclusively whatever is required, error data alone I am reading and keeping in the cache. So what is the count of the error records? 4 lakh records. Meaning my entire logic is also going to apply on the 4 lakh records only, but not on the 1 terabyte of the data. That is where this much of the performance scale. Is it clear now?
Okay. Okay. Yes. Yes.
Yeah, now. So if you look at all these things by what we can understand here, look at here, sir. I will again go back to this original diagram. In the storage, there is no problem. Absolutely, it is good. That we agreed. Perfect. But in the processing, there are some good amount of the design level drawbacks or processing related drawbacks that we are having. So in order to address the processing related burdens of our Hadoop only, Spark framework got evolved. Now let's come to the point, sir. What is the significance of this Spark framework? Spark is a big data processing framework, which is meant for processing the data in a in-memory cluster computing model. Sir, without using the term in-memory, there is no meaning out of Spark, because the main central theme of our Spark processing is in-memory processing only. Okay, and second point, Spark is only meant for processing, but not for storage. Okay, Spark is from Apache vendor, and it is a open source framework. Like Hadoop, Spark is also a open source framework. Okay. So now with all these points, what I'm trying to say, can we say Spark is a substitute or replacement for Hadoop? Can we say Spark is a replacement for Hadoop?
No,
What is the reason?
it is not for storage, right?
Very good. So Spark is only meant for processing, whereas Hadoop is meant for both storage and processing. So Spark is not a replacement for Hadoop. Very good. Now, is Spark is a replacement for MapReduce?
Yes.
Because Spark is also meant for processing part of the data. MapReduce is also meant for processing part of the data. 99% people will think in the same way, but unfortunately, Spark is neither a replacement for Hadoop nor for MapReduce. Why? What is the reason for the second point? Because, yeah, MapReduce, we can use it for unstructured data processing as well. But however, Spark is not matured enough to process the unstructured data, including the recent versions as well. The libraries have not been added to process the unstructured data from Spark. So there is a small problem in that regard. So that's where what I'm trying to say, Spark is neither a replacement for Hadoop nor for MapReduce. It is only a complementing technology for Spark. Meaning whatever we cannot address in Hadoop, to complement the same only, we are making use of Spark as an extension to our Hadoop only. So that is what the main purpose of using the Spark framework. So till now, is everyone clear?
Clear.
Yeah, fine. So now, yeah. So now we are going to move on to different modules of Spark, what we are going to use. Sir, in comparison with Hadoop, only I will discuss so that you will also understand better. So here on the left hand side, I'm writing the Hadoop components or Hadoop tools, whatever it might be. On the right hand side, I'm writing the Spark modules. We will call modules. Okay. So when I say HDFS, what is the relevant component from the Spark side? Can any one of you please? Sir,
It is
my
the
question
same.
itself is wrong because HDFS is purely meant for storage part of the data. Is Spark anyway meant for storage? No. So what I can say, not applicable. The question itself is wrong. Okay, now, sir, either you are saying map reduce or pick. These are the map reduce or pick. So at a core level to process our data in our Hadoop we are using. So the relevant module from the Spark side is Spark core. Spark, there is a module. The name of the module is Spark core. Next, from the Hadoop side, we are having a component called Hive. How to keep the data in a data warehouse, like in the Hive tables, and how do we process the data using some querying mechanism. That is what the purpose of Hive component. So similarly, in our Spark side also, how to maintain the data in a tabular format and how do we work with the same kind of the data. In that regard, we are having a module called Spark SQL. Okay, yeah, next. From the Hadoop side, we are having something like Flume in order to bring the live streaming data, Kafka, or some Storm, one more other tool. So they are only exclusively meant for live streaming data ingestion, not for processing. But here, coming back to our Spark, there is a separate module we are having called Spark streaming module. Spark streaming module. So here we are making use of this one, sir. We already discussed one point. Hadoop is only meant for batch processing alone. It cannot address the near real time or real time processing. However, using Spark streaming, we can very well accommodate near real time processing and real time processing. Using the above components, we can very well address the batch processing. So altogether, in Spark, we can do any kind of the processing. Either it is a batch processing or near real time or real time. Any type of the processing we can do very well. Yeah, next. So from Hadoop side, there is a component called Mahout in order to drive the big data analytics. So in order to drive the big data analytics with the help of some algorithmic solution from Spark side, we are making use of Spark ML lib, machine learning libraries. So that is what the module, the corresponding module what we are using. So the next module, we don't have anything here, no, but separately in Spark alone, in order to work with the graph related data, there is a separate module we are having called Spark Graphics. Okay, so these are the total 5 modules what we are going to use in our upcoming classes. In our upcoming classes, we are going to use these complete 5 modules only. Okay.
What about PySpark, sir?
No, no, I'm coming to that. Coming to that. So these
Okay.
are the total modules. So, sir, in order to drive the Spark processing, modules are complete altogether. So to drive the Spark processing, there are 4 compatible languages we are having. So the very first language is Scala. Second language would be Python. Third language would be R. Fourth language would be Java. However, we are in the real world, we are predominantly going to make use of either Scala and Python only. More than 90% of the cases, we are going to use these particular 2 languages only. And especially if you are driving the Spark processing using the Python language, that is what we used to call PySpark. That's it, nothing more. So PySpark meaning you are doing the Spark processing with the help of Python language. That's where PySpark. Okay. So in our weekend batch as well, I will totally show you the Spark processing with the Scala and with Python as well. And you can ask me, Gopal, I don't know the Scala language and I don't know the Python language as well. Then how can I understand? That is why in our Spark weekend batch also, initially I am going to start with Scala only, followed by Python. Afterwards only we will jump on to Spark. On the very first day itself, I will not directly jump on to Spark and I will discuss all the things, because without knowing the Scala and without knowing Python, if I am directly showing you the Spark processing also, how can you understand the Spark processing? It is something like, without knowing English language, if I am showing some English story also, will you understand over there? No. So it is also in the similar lines. So first I will discuss Scala, then only Python. And if you ask me what are the prerequisites for learning Spark, yes, you need the basic SQL commands that anyway we should require. And very importantly, Hadoop basics you should know, sir. Because without knowing Hadoop, you cannot explore on the Spark framework. Why? Because Spark framework got evolved as an extension to our Hadoop framework only to address the processing related drawbacks of Hadoop only. Spark framework got evolved. So at least some basics of Spark you should know. So my sincere advice is both Hadoop and Spark you can take in parallel. So you please discuss with our front office team. They will suggest you if you can join in both Hadoop and Spark batches in one go within the 2 months of stipulated time only. Yes, you can very well complete both of them. But sir Gopal, you are saying without knowing Hadoop basics, you cannot explore on Spark. That is why we are going to start with the Scala and then Python. By that time, I will complete all the stuff in the Hadoop side so that there won't be any glitch in the way of understanding the things. So I will take Hadoop course and Spark course only. So I will take care of completing all the prerequisites before we are going to start Spark. Okay. Yeah. Next. Sir, I am going to provide 2 real-time Spark projects, which you can also include in your resume if you want, because I am going to discuss in a detailed manner, including the code walkthrough and the detailed documentation as well with resume preparation help. The very first one is e-commerce domain project. So as part of the same Unilever customer project we are going to discuss. And second is finance domain project. So TD Bank project I am going to discuss. So these are the 2 projects what I am going to discuss exclusively in the Spark batch. Okay, in and out I will discuss. And sir, if you are going to learn this particular Spark framework, the pay package is also going to be extremely high. In fact, you cannot even compare with any other technology. So for the brand freshers as well, like 2022, so 23 passed outs or something, 6 lakhs package to 8 lakhs package is quite guaranteed for the mid-range experienced candidates, 4 years to 8 years of experience holders. So the general pay packages are 13 lakhs package to 28 lakhs package. And recently, one of our batch member whose overall IT experience is 11.5 years of experience, and he kept 3 years of experience on Hadoop and Spark, and his pay package was 45 lakhs per annum. So why I'm giving all these examples? Because when you are going to explore on the Hadoop and Spark frameworks, opportunities are going to be very, 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 very high, and pay packages you cannot even compare with any other technology in the market. That much of the high-end packages you are going to see. Okay, and as nowadays good amount of the projects are also getting migrated into cloud platform, especially in our course Azure Databricks. So it is one of the Azure cloud related implementation of this Spark. Azure Databricks I am going to discuss in a good amount of good amount of portion I will cover. So how exactly we are going to drive the Spark processing under the Azure cloud using Databricks. That's what I'm going to discuss as part of the class, so that you will get some good exposure on the cloud integration point of view as well. So these are all the things what we are going to discuss in our upcoming classes. Sir, I'm pretty much done with my demo. So if you have any open questions, please ask me now.
Sir,
Hi,
Hadoop
Mr. Gopal.
basic means. So,
Yes,
Go
Ramesh.
ahead, go ahead. Okay. So, Mr. Gopal, I have a question here. Uh, Spark is open frame, this open source, right? So, I understand that Databricks is something, what do you call, prize tool, right?
Yeah,
So,
it is
is there
not.
any additional? Am I audible to you?
Yeah, yeah. Go ahead.
Yeah. Yeah. So, I mean, I'm just comparing Spark and Databricks. In data, let's say Azure Database. I mean, currently I'm working in a Snowflake environment where I
Okay.
need to use Databricks for processing to process some of the live data. This is what my current project scope. That's why I attended this class to understand more about Scala and Spark. So my
Okay.
question is, uh, using the open source Spark versus Azure Databricks, do we
Hmm.
get any other tools or anything extra on top of the open source which helps us to deliver the product better?
No, no, no. So that's not the way, sir. Like if at all you are making use of any cloud service, either it might be Amazon Web Service, AWS or Azure or GCP or anything, cloud is something like pay as you go. Whatever the amount that you are been using, that much you have to pay as any kind of the cloud service. But within the cloud infrastructure only, if you are not doing the project on premises, it is a cloud integrated project. So Databricks is one of the service what they have been facilitating in order to drive the Spark processing. So it is not open source. However, community edition is there. If at all you are going to make use of a community edition, so there won't be any charges. You can use free of cost. But if you want to launch your entire application on the cloud environment, and if you want to use Databricks, it is not for open source. For the usage you are using for 5 months or 6 months or 7 months. For that particular tenure, you have to pay the cost towards the cloud. It is not for whatever the Spark and all. Towards the cloud maintenance and the cloud rendering, you have to pay the amount to the cloud. Here there are two concepts, sir. As such, Spark is a open source, provided if you are going to use on the on-premises model. I will download and I will install on my machine and I will use it. It is absolutely zero cost. But you are using on the cloud environment. Cloud is not free, right? If at all you are using free subscription, 1 month tenure you can use freely. But once 1 month is over, everything is chargeable on the cloud environment. So for that you have to pay. Hope I cleared your question.
Yes, yes. I have an additional question. Does this, since it is we are paying for whatever the cloud and database, does they complement with any tools like orchestration tools? Just trying to understand if Databricks is giving any complementary tools to orchestrate the jobs or something like that. Just want to understand the ecosystem of
No,
Databricks.
airflow and all will be there as part of the scheduling and all. But if you want to make use of some other Oozie or airflow kind of the tools as well, that is also payable. It is not coming up with any complementary service. No.
Okay, okay. Makes sense. Thank you.
Yeah.
Then what
Any other?
softwares have to be installed in our machines?
Yeah, yeah. So